Okay, class, we'll look at the question now. So, all right, for this question, we have the forces. Okay, we have three forces here. They are acting on a particle A, okay, which this particle is in equilibrium. All right, so first one is to evaluate the P and the theta. So for this one, I think it is easier for us to use the resolving the forces to vertical and horizontal. Okay, so if we actually consider first one, when we consider the vertical, okay, so what we have for the vertical forces would be, we have 4 sine 30 degree, okay, is equals to P sine theta in this case. So we only have one force which is going up, another one which is going down. Okay, so after that, okay, we actually have the horizontal component, okay, of all the forces. So to the left, we have got 8. And to the right, we need to resolve the two forces there. So we have got 4 cos 30 degree plus P cos theta. Okay, so this is where we actually get two equations. Alright, so from there, okay, we let's say we rearrange a little bit for the second equation first. Okay, so for the second equation, we will actually get P cos theta is equals to 8 minus 4 cos 30 degree. Okay, so what is the reason that we do this is because let's say we want to find the value for the theta first. So we have got the first equation from the vertical, and just now we already have another equation. So in order for us to get the theta, we can actually divide the first equation by using the second equation. So left hand side we actually get the tangent theta because we have the P will cancel off, and just write in the numbers. We have got 4 sine 30 divided by 8 minus 4 cos 30 degree. Okay, so for this one, we actually get a nice value from there for the tangent theta. So the theta here we actually have 23.8 degree. Alright, so this is what happened to the value for the theta. So if you want to find, in this case, the value for the P, we just have to make use of any equation that we have. Say if we actually use the first equation, so what do we have is we have got P sine theta, which is 23.8 degree, is equals to 4 sine 30. So from there we can actually find the value for the P lah. Okay, so that will be 4.96 Newton for our P. Okay, so that will be our first part. Alright, for the second part, we can actually look at the question. It says, okay, the force 8 Newton is removed. So state the direction of the instantaneous acceleration of A. So in this case, what happens is that initially this particle is in equilibrium. So what it means here is the 8 Newton, okay, the force is equals to the forces which we resolve, okay, to the opposite direction to the 8 Newton. Okay, so the 4 Newton when we resolve, and then the P Newton when we resolve, we will get this, okay, force which is just enough to overcome or oppose the 8 Newton. So if we actually remove the 8 Newton, so what we have, okay, remain is this force. Okay, so from there we know that this force is a force which is going to the right. Okay, so for the second part, okay, the direction is to the right. Okay, so that will be for this second question. Sorry, the second part of the question. All right, so let's look at another one. Okay, let's try this question first. Okay, let's look at this question. Okay, so it is again an object with weight 60 Newton. It's supported by in equilibrium, okay, by a force of P Newton and also the 10 Newton, okay, which they have the angle which is 30 degree and theta degree respectively. So, okay, first draw a triangle to show that the forces acting on the object are in equilibrium. So, of course, there are a lot of ways that you can actually construct your triangle. Okay, so for this one, okay, what we can do is just make sure that because this is an equilibrium, so when we actually construct the triangle, the arrow that they are pointing, the direction of the forces must be either clockwise or anti-clockwise. Okay, so if that is the case, one of the possible triangle that we can actually do is that we can actually move the 16 here. Okay, and then we have the P, which is like this. Okay, so after they just label the angle, so the angle here is a theta, okay, because of this Z shape, right? And we also have the 30. Okay, so for this one we know this is 150 minus theta. Okay, so that is where we get our triangle. So after that is to find out, okay, the two possible values of the theta, okay, and the corresponding values for the P. So for this one, okay, we can actually use any rules, okay, from the triangle. So for this one, I think it is good for us to use the cosine rule. Okay, so for cosine rule, what we can do is let's just use the side which we have the 10 Newton and the angle is a 30 degree. So from there, okay, if I actually refer to this triangle, so what we have is that, so in that case, we will have 10 squared equals to 16 squared plus P squared minus 2 times 16 times P, and we have a cos 30. So in this case, try to keep the exact value for the cos 30, which is root 3 over 2. So when we actually do the calculation, root 3 over 2, and just rearrange this, okay, we will actually have a quadratic equation. Okay, so this is a quadratic equation that we actually obtain. So this is why we actually have two values of the P with two values of the theta in this case. So from here, nothing much, we just have to solve for this P. So always remember, when we cannot factorize the equation nicely, we must always show the working. So when we actually try to show the working, in this case we are using the quadratic formula, so make sure you really write that out carefully. Okay, so of course this one you know how to do lah. Okay, so for this one, evaluate this nicely, okay, and we will actually get two values, which we have 8 root 3 plus minus 6. Okay, so this is the value that we actually get. So from that we actually get two values of the P. So the P could be 8 root 3 minus 6, okay, which in this case is a 7.86 Newton. Okay, or we can have the P is equals to 8 root 3 plus 6, which we have 19.9 Newton. Okay, so for this one we can actually use, because we have the P here already, so we can actually use other rules for the triangle to help us, okay, to find out what is the value for the theta in this case. So for this case, okay, we can use a sine rule, let's say. So we use the side of the P, okay, with the theta, okay, opposite to it. So we have sine theta divided by 8 root 3 minus 6. So this is equals to sine 30 over 10. Okay, so for this case, what we have is we have the theta is equals to 23.1 degree. So for the angles in degree is 1 decimal place. Okay, so for this triangle, right, okay, we just look at what is the triangle that we have drawn just now. So the triangle that we have just now is like this, right? Okay, so let's just draw this triangle, okay, with the values of the p and the theta that we have found and see whether it is valid or not. So for that one, we have this is a 10, and then we have the theta, which is 23.1, okay, and then we have the 30 degree, and then here the length is a 16, this one is a 7.86, and then this angle is 126.9. So for this triangle, it seems it seems very logical. Okay, looking at the angles and the sides, this triangle looks quite logic. Okay, so you will see why we have to do this when we actually look at the next value for the p. Okay, so for this next value of the p, what we actually get from there is we use the same thing. Okay, we use the sine rule again. So in this case, we actually have the theta. So the theta here, if we solve the value for this one, we will get 83.1 degree. Okay, so it seems like this is the answer already, but let's just have a check, okay, whether this triangle looks logical or not. So we have got, okay, again, we have got this is 16. Okay, and then now the theta that we have is 83. Sorry, this is 83.1, and then here the length is a 10, and here what we have is this is a 30 degree, and then this length is a 19.9. Okay, so by looking at this triangle itself, it is not so logical. Okay, because we cannot have the side which is having the length of 19.9 to appear like this. It's a bit weird. Okay, so we cannot take this data. So what is the value of the data that we should take is that, okay, because what we are trying to do is somehow before we get this value of the data, right, we are solving something which is sine theta is equals to a positive value. Okay, so for this positive value for the sine, we have got first and the second quadrant. So the value that we have got just now is the answer in the is the first quadrant. So it cannot be accepted because it is not logical. So what we need to do is we have to find out the theta, okay, which is in the second quadrant. So we have to use 180 to minus this angle in the first quadrant in order for us to get the angle in the second quadrant. Okay, so once we have this theta already, the triangle will now make more sense. So if you actually do a rough sketch to it, so this is how our triangle will look like. Okay, which in this case is it makes more sense already. Okay, so we cannot take the value for the 83.1, but instead we have to consider the value which is the theta in the second quadrant. Okay, so you can actually see here the second triangle actually makes more sense. Okay, it will be clearer if you actually follow the scale and the correct angle to draw it. Then you will see why is it like that. Okay, so this is the thing that we have to be careful whenever we work with the forces and with the triangle, and when we actually try to solve for the sine theta in this case. Okay. All right. Next question. So for this question, I'll give it to you as the exercise, okay, because it's a proving question. So later I'll upload this question for you all. Okay, so we'll look at the another question. So this is the question. It's a bit long, but we can actually try to solve the first two parts first. Okay, you can take your time to work on it. Okay, let's look at the questions together. Okay, first one. Show that the normal reaction is given by the expression. So I guess you have already looked at the situation very clearly. The figure given is also quite clear already. Okay, I think we should just proceed to look at the forces. So for the forces that we have in this case, okay, that would be we know that for B, okay, the mass is M, so we have got mg, so we have a tension. Okay, this is a string, so we have got a tension. And for the A side, okay, we have got also tension, and the mass of A is 2m, so we have the weight is 2 mg, and the normal reaction force, okay, the R. Okay, so for this one, okay, in order for us to find out what is the expression for the R, is first we look at the B. So at the B side there, the particle B there, we have got the tension is equal to the mg, so this is quite clear, okay, if we look at the particle B. So as for particle A, so what happened for the particle A is that we are trying to resolve the forces to the direction of the reaction force. So what we have for the reaction force there is we have got the reaction force, okay, and another force which is going up, which is going at the same direction as our reaction, is that we have got T sine alpha. Okay, and opposite to those forces, we have got the 2 mg, but we have to resolve this 2 mg. Okay, so when we resolve this 2 mg, we get 2 mg cos alpha. Okay, and then we know that the T is a mg, right? So we have got 2 mg cos alpha minus T sine alpha. So the T is mg. So basically from there, it's just factorizing the mg out. Then we will get the expression nicely. Okay, so that would be the first part. So for the next part, okay, how do we actually show this? Okay, so for the second part, right, it's actually to show that the R takes a certain value. So for this R is greater or equals to 1 over 2 mg root 2. So it means the R, okay, will have a minimum value at which is 1 over 2 mg times root 2. So how do we actually get this is we can actually look at the expression that we have in the part 1 first. So in part 1, what happens is that this is our R, right? Okay, and in our second part, okay, the inequality, they both contain the mg. Okay, so what is the remaining terms? The remaining terms will be 2 cos alpha minus sine alpha is root 2 over 2. Okay, so we have to try to think of a way to actually prove that this expression for 2 cos alpha minus sine alpha is greater or equals to 2 root 2. Root 2 over 2. Okay, so let's see how do we do that. So let us just write out what is the expression for R first. Okay, so in this case, okay, because we know that the alpha is already given is less than 45 degree, and of course the alpha must be also greater than 0 lah. Okay, we cannot have the alpha which is something negative ma. So just look at the ranges for the cos and the sine alpha. So for cos alpha from 0 to 45 degree, so cos 0 is a 1, okay, cos 45 is a root 2 over 2. So this gives us 2 cos alpha is in between root 2 and 2. Okay, we can do the same thing for the sine alpha. So when alpha equals to 0, sine alpha is a 0, and when alpha is a 45, sine 45 is root 2 over 2. Okay, so if we actually consider the whole thing together, 2 cos alpha minus sine alpha. So we want to say that, okay, this thing is greater or equals to something, because we want to prove that the R is greater or equals to. So we have to show that this expression 2 cos alpha minus sine alpha is greater or equals to root 2 over 2. Okay, but how do we know it's greater than root 2 over 2? So it's by looking at, okay, we have got two terms here, right? We have got 2 cos alpha and minus sine alpha. So by manipulating these two terms, how do we get the minimum value for this expression? Okay, so in order for us to get the minimum value of this expression, what we need to have is this one must be the minimum and the sine alpha must be the maximum, so it will result in something which is minimum because it's a minus. Okay, so the minimum value for these two cos alpha in this case is a root 2. Okay, and the maximum for the sine alpha here is a root 2 over 2. Okay, so in that case, we will actually obtain the 2 cos alpha minus sine alpha is greater or equals to root 2 over 2. Okay, so we just apply this inequality into the R law. So since R is equals to mg 2 cos alpha minus sine alpha, and the expression in this bracket is greater or equals to root 2 over 2, so we can say that this R is greater than half mg root 2. Okay, it's by replacing the 2 cos alpha minus sine alpha with this root 2 over 2 and say that it is greater or equals to, okay, for this expression for the R. Okay, so this is basically how we do part 2. Alright, so let's look at the question in part 3 and part 4. Okay, so I guess you have the sketch already, so maybe you can look at how do we do part 3 and part 4. Okay, let's take time to try this first. Okay, let's look at this one. So, okay, now, okay, they tell us that, okay, the coefficient of friction is mu, and particle A is about to slip down, okay, about to slip down. Okay, so this is the important info that is given to us. So show that the tangent alpha is in between 0.5 to 1. Okay, so how do we actually see this is that, okay, now, so we actually see that, okay, what is the situation that the particle A is about to slip down. So it actually means that if it is about to slip down, okay, there is a friction which is going up the slope. Okay, so as you can see here, there is a friction that is going up the slope. So why do we have a friction which is going up the slope is that there is the combination of the forces which this particle will actually slides down. So to prevent it to actually slides down, okay, we must have a friction which is going up from that. Okay, so in that case, when we actually consider the forces that is the same direction as the friction, which is like parallel to the slope, is that we have got, in this case, we have got the 2 mg, okay, which is, we resolve it downward. So for this, we have got 2 mg. So when we resolve it down the slope, we will actually have sine alpha, okay, and for this one, we have some force, okay, which is opposing it. So the force which is opposing it is the T when we actually resolve it up the slope. So we will actually get T cos alpha. So what is the net effects of this? So 2 mg sine alpha is going down, okay, so T cos alpha is going up. So for these two forces, okay, when we use the 2 mg sine alpha to minus the T cos alpha, it must be greater than 0. Okay, so greater than 0 means 2 mg sine alpha is greater than T cos alpha. So it means there is a net force which is going down without considering the friction. So the net force, okay, which is going down the slope is overcome, okay, by the friction which is going up. So this is why we have this greater than 0 sign here. Okay, so from there what we know is, we know earlier on the T is a mg. So we have got 2 mg sine alpha minus mg cos alpha is greater than 0. So by rearranging this, it is quite easy for us to actually obtain the tangent alpha. Okay, so for this tangent alpha, it is greater than 0.5. Okay, so this one sort of like shown, okay, half of the inequality. So how do we actually show another part of the inequality is, remember, the value of the alpha given in this case is less than or equals to 45 degree. So in that case, because we have the alpha is less than or equals to 45 degree, the value of the tangent alpha has a certain limitation. No? So in that case, the value for the tangent alpha must be less than or equals to 1 because it's 45 degree. Okay, tangent 45 is a 1. So when we actually combine the two inequalities together, so we are able to prove this. Okay, tangent alpha is in between 0.5 to 1. Okay, so that would be for our part 3. Okay, so as for part 4. Okay, so what happened to the part 4 is that we are supposed to express mu as a function and deduce its maximum value as alpha varies. Okay, so for this one, we can actually find out, okay, what is the mu r, the friction law. So in this case, the friction that we have, the mu r, okay, remember for this mu r, right, it is equals to the net force which is going down. Okay, because we want to overcome that one. So we already found that force, okay, in the previous part. So in the previous part, we just have to use this expression, this one. Okay, the 2 mg sine alpha minus T cos alpha from there. So we have got 2 mg cos alpha minus T, which is mg sorry, I made a mistake here. This one should be a sine alpha minus, this is t cos alpha. Okay, so because we want the mu, right? So the mu is just, we have, let's just factorize out the mg. Okay, and earlier on we actually already have found what is the expression for the r. Okay, so the r here is, we have got mg, we have 2 cos alpha minus sine alpha. So this is the expression for our mu. We can actually cancel off the mg in this case, for which we will get an expression which is entirely in terms of the cos and sine. Okay, so when we have the cos and sine, we know how to change it to the tangent. Okay, so we can change it to the tangent by dividing cos alpha for all the terms. So we will get 2 tangent alpha minus 1 divided by 2 minus tangent alpha. Okay, so this will be the expression for our mu in terms of the tangent. Okay, so after that, we want to find the maximum. So we are looking for the maximum mu. Okay, so how do we actually find the maximum mu? So in this case, the value of the mu actually depends on the tangent alpha. So of course, the tangent alpha would depends on the alpha. Okay, so by using this expression alone, it is not so clear that we can actually find the maximum. By looking at the behavior of the tangent alpha, it might be not so clear. So what we can do here is we can actually try to simplify a little bit, okay, into something which has lesser term, which is the tangent alpha. So what can we do here is we can try to do some long division if we want to. So we use 2 tangent alpha minus 1 to divide by negative tangent alpha plus 2. Okay, so we can actually use negative 2. So we have negative 4 here and we have a 3. So by rewriting this, okay, term into the fractions, it is very helpful. So now we only have to worry about one single tangent alpha term. Okay, so now what we are supposed to find is we are supposed to find, okay, the maximum of the mu. Okay, so the maximum of the mu will depend on our denominator. So we must have the minimum value for our denominator. Okay, so how do we actually get this minimum value for the denominator is that we need to have the tangent alpha is as large as we can, because we are using 2 to minus that one. So we are using a 2 to minus the largest value to give us a smallest value overall. Okay, so remember in the previous part we have already proven the tangent is in between 0.5 to a 1. So in this case, okay, when we have the tangent alpha is equals to 1, so the maximum mu that is going to give us is negative 2 plus 3 over 2 minus 1, which will actually get a 1 for the mu. Okay, so the maximum mu that we can get here is a 1, okay, when we have the tangent alpha is a 1. Okay. So I guess that is it for the discussion. So I'll see you in another video. Thank you.